So that was about mapping, visualization, and content. Now we'd like to talk about analytics and just go back to what I was describing at the end of my overview. Our agenda here for this section is to first talk about the user experience and the insights application. Then we'll drill into feature analytics and raster analytics, and we'll sandwich some of our work on real-time GIS in between. We'll follow that up with the scripting and Python API that exposes these analyses against big data, and finally wrap it up with the summary of the WebGIS architecture that lets you deploy all of these. So we'll start it off and with insights with Art and Linda. Here they are.
Thanks, Sud. We all know data is important, but it's not as important as the answers it provides or the stories that it tells. Insights is a new experience we're adding to ArcGIS that enables exploratory and interactive spatial analysis using maps, charts, and tables in a very easy-to-use, fast, and very friendly environment. But perhaps the best way to talk about this is to actually see it. So let's ask Linda to give us a sneak peek. Linda?
Thanks. With the insights, we're introducing the concepts of workbooks, pages, and cards to ArcGIS. On import, the data type is automatically determined, and that defines the functionality of that data, but it can very easily be changed. You visualize your data on cards as either tables, charts, or maps. The legend allows you to interact directly with that data. And you'll also notice the interactivity between all of the cards. So let's explore this data set. So this is 2 years' worth of crimes across Philadelphia. We see that there's been generally a decrease of crimes over the 2 years, but that some of the residents are actually reporting an increase of residential burglaries. So let's have a look at the residential burglaries and see if changes over time explains that difference. If I drag the date field and create a chart, you'll see immediately a timeline is created for me. With the interactivity between the cards, you can see those changes over time. But perhaps with so many points, it'd be better if I changed the map type. Now we can explore those patterns changing over time across the city. So you'll notice that there aren't a lot of spatial temporal changes, so clearly time isn't the thing that's having the difference. So let's start a new page. I can connect and add in data to any page that I have. So I'm going to add in some police districts. Analysis is very much a part of insights. The data format determines the kind of on-the-fly analysis that can be done, either through drag and drop or by using the action button. So now I can aggregate those crimes to my police districts to explore more local patterns of crime. So to do that, I just need to drag that layer into my card, and it's immediately aggregated for me. Do you see how easy we've made that? I can even undo every step. I can drag that again. So now we see a polygon overlay really is as easy as just overlaying your polygon. Throughout the experience, in order to interpret these visualizations, we have statistics. You can see the value by location, but in context to the whole data set. We see the minimum, we see the maximum. On the back of the card, we also have the statistics for all the data on your map. Any spatial data that's created can be immediately interrogated. So now we can look and see the total number of crimes by our police district areas. You can change the chart type directly on the card. So if I repeated that across 2014 and 2015, we can immediately see by working with the interactivity between the charts and the maps that in both years, District 15 had the largest number of crimes. But interestingly here, we see that District 35 did indeed see an increase in the number of crimes in 2015. But totals don't tell the whole story. We often need to normalize our data to take into account, for example, different sized populations. So let's have a look at the rate in each one of these areas. And let's see, in fact, if rates and total crimes increase in exactly the same way. Now we see that, indeed, rate does increase with the number of crimes, but if we look at those statistics, we see that the relationship is very weak. So let's use the rate, because that determines the amount of people who've been impacted. And now I'm going to look at the percentage change between the 2 years by district. I'm also going to map my rates. And now I can see immediately that there's been 4 districts in which there has indeed seen an increased number of burglaries, and in particular, district number 35. So that's my analysis done. But for me as an analyst, there's one really important thing I'd like to share with you. Throughout that whole analysis, everything I've done has been automatically recorded for me. My workflow has been documented for me, a model has been created, I can share that with other people, they can repeat my workflow with their input data. Thank you. Art?
Thanks, Linda. That was a great sneak peek of what's coming up. Insights is a modern browser application that's based on a design-first approach, using the JavaScript API and the capabilities within the ArcGIS platform that enables all the spatial analysis. We also leverage TypeScript, Angular 2, Bootstrap, and Sass as part of the development. We'd like to invite you to consider alternative experiences that makes use of the spatial analysis capabilities of ArcGIS, similar to what we have here. This is a great week to figure this out. Thank you. Suzanne, let's continue this on.
Thanks very much. So many of you are struggling to work with big data. And big data, as you all know, comes in many forms. One type of big data, for example, is spatiotemporal event information. In this case, we're drawing 1 billion financial transactions across the US. The problem with this kind of data is that it's so large, to visualize it, you'd have to wait, and wait, and wait, and see if it ever actually stops drawing. The only way to truly visualize 1 billion records is to aggregate it into something that you can understand. So how did we create this aggregated layer? We've been working hard to enhance ArcGIS to do batch analysis on these kinds of huge data sets. Geoanalytics will be a new capability in ArcGIS that lets you run spatial analysis as distributed processes across a cluster of machines. The geoanalytics tools are geared to help you understand your data. You'll be able to find hotspots, create buffers, calculate densities, and do aggregations so that you can reduce and summarize your data in ways that allow you to explore patterns. The geoanalytics tools would be accessible from Pro, from the online web experience, or from your own apps via REST API. Geoanalytics tools can be run on a cluster of machines, so you can perform bigger jobs than ever before. For example, in this case, we aggregated those 1 billion financial records by the nearly 74,000 census tracts in the US. Now, seeing patterns is a good first step in understanding your data. But often in these mountains of information, what analysts are looking for is that needle in the haystack, the activity that's actually different from the normal pattern. And in the case of financial data, often what analysts are looking for is waste, fraud, and abuse. So what does fraud look like? We're going to take a look at a quick example of how money laundering plays out on the ground. So one technique often used by criminals to move large sums of money around is to split it into multiple transfers. One or maybe a few people will quickly visit multiple financial institutions and submit transfers that are all below the official reporting threshold. Many of our users, and indeed many of you, have domain expertise not unlike this. You understand how abnormal or illicit activity can play out, but how do you actually query for that? How do you teach a system to detect that kind of behavior? To find this, for example, you'd have to consider distance, time, the recipients, the amount of money, and then you have to do it all 1 billion times. Geoanalytics includes new space-time tools that allow you to ask these kinds of questions in entirely new ways. For example, the Join Features tool allows you to find associations between features based on attributes, based on spatial relationships, but also based on temporal relationships, and all three of these at the same time. So this is multiple dimensions of relationship analysis, and it's never been possible before at this level of space-time detail. We used join features in this way to mine these financial transaction records for this fraudulent behavior. So let's take a quick look at how that works. With geoanalytics, you can work with your data. You'll be able to work with traditional geospatial formats, or you can attach your big data to ArcGIS, for example, as file shares. Now, to find this fraudulent activity, what we focused on were the origin locations of these transactions, like the example that you see here. And we joined these origin locations to themselves. So for every single transaction, we asked how many took place within a kilometer and an hour of it that were going to the same recipient. And we can calculate statistics on any of the input fields as a part of the geoanalytics tool, so we can sum the total amount of money involved and use that to refine the results. Using a cluster of 20 nodes, we ran join features against 1 billion records in 48 minutes. So 48 minutes to burn down that haystack and find all of the potential needles within it. And what we're left with are just those clusters of transactions from the same, starting in the same small area, that went to the same recipient in a different location. And we can use the amount of money and the number of transfers involved to isolate the most suspicious behavior. Imagine running these kinds of analyses and building on these tools so that you can find abnormal patterns in your own data or reduce and aggregate data to provide meaningful data products in your own solutions. Geoanalytics will bring the power of distributed processing to your vector big data and give you entirely new ways to mine information across space, time, and signal. Let's close with a quick summary view of the architecture at a high level. So geoanalytics, through geoanalytics, you'll be able to attach your big data to ArcGIS from either registered or managed data sources. And again, the analytics is executed across a distributed and scaled cluster of machines. Results are written to either the relational or the spatiotemporal big data store, and this means they automatically become new web GIS layers that you can visualize, you can mash up, and you can use in any part of the ArcGIS system. Thank you. I just wanted 2 rounds of applause. Now, we're going to talk about some of the enhancements to our real-time GIS product. So these days, as I'm sure you're all experiencing, new data is coming at us all the time, from all kinds of different sources, sensors, and devices. So for those of you who work with real-time data, the GeoEvent Extension for ArcGIS lets you monitor that data, do in-stream analytics, detect incidents, and send alerts. What we're looking at here, for example, is a data stream of current flights and their positions over the US. But as information keeps coming in ever higher volumes and velocities, it's hard for traditional systems to keep up with that data and store it for analysis at the same time. So in version 10.4, we've entirely redesigned the GeoEvent architecture, and you can now capture features to the spatiotemporal big data store. The big data store is a new part of ArcGIS that also takes advantage of distributed computing technology and gets you past previous bottlenecks so that you can capture up to tens of thousands of features a second. What we're looking at here is GeoEvent running up in Amazon. Individual flight positions are coming in at up to 500 features a second. And using the big data store, we've been ingesting this flight data for the past 3 weeks, storing it, and so far we've accumulated over 300 million historical flight positions. This is using an 8-node cluster of machines in the Amazon cloud. The big data store provides you the elasticity and scalability that you need to work at the speed of your data. Now, these architectural enhancements also include new and dynamic ways to view this information. You can configure your GeoEvent maps to dynamically aggregate your data by bins so that you can make sense of millions and billions of observations. So what you're seeing here is everywhere that a plane has flown in the last 3 weeks. Hundreds of millions of observations are being summarized on the fly with each pan and zoom of the map. The bins update, they get more refined as you zoom in. You can calculate additional statistics on any of the bins. And at any point, you can bring up the pop-ups for all of the individual data points or events that are being summarized in each one of these bin cells. For the first time, you can have a dynamic pattern map that never goes out of date. And these on-the-fly aggregations are immensely helpful for understanding your data. For example, as we get closer, it's easy to see the takeoff and landing patterns that form around each airport. There's an incredible depth of information here. And being able to aggregate this data and work with it effectively opens up opportunities for forensic analysis, because you can search and query data that's in the spatiotemporal big data store like it was any other layer. So for example, every few weeks I take United Airlines Flight 1602 from San Francisco to Atlanta. And after cataloging all this data and storing it for the past 3 weeks, we mined all 300 records for the United Airlines for this particular flight and recreated the route so that we could study the deviations. Imagine the possibilities for understanding normal and abnormal behavior in your data when you can capture and store and work with all that information. Now, along with these kinds of forensics, you can also replay your real-time data. So on February 15th, when it was warm and sunny here in Palm Springs, the southern states were dealing with storms and tornado watches. And as we combine the historical flight data with the historical weather radar, it's easy to see the course deviations that the pilots made as they navigated around the storm cells. As the Internet of Things becomes ever more pervasive, there's going to be more and more real-time data for you to know if things are on track, but your historical information becomes even more valuable for optimizing your systems. The GeoEvent Extension allows you to monitor real-time data, and now combined with the big data store, you can store and work with your information effectively to keep building a smarter world. Thanks very much. And next, I'm going to hand it over to Vinay to show you guys some of the amazing enhancements that his team has been doing with raster analytics. Vinay?
Thank you, Suzanne. So harvesting the energy of the sun is critical. In this demo, I'm going to be using the power of the new raster analytics capability to process large landscape data sets to derive a map, a suitability map. So here are the data sets that I'm going to be working with. They reside as data sets on my WebGIS. First is the flood risk, which will be helping me to exclude my flood zones. Next is the slope data set, which will help me identify terrain, treacherous terrain. Then I have mean temperature, rainfall, and lastly, my land cover data set. Now, ArcGIS Pro, it provides you with a slew of raster functions out of the box. So I could easily apply a vegetation index. I could apply arithmetic operators or radiometric corrections to my imagery. Now, each one of these functions, they can be chained together to create your own custom function chain. So for instance, in this case, I have my pre-built function chain, which will build my suitability map. And using this intuitive modeler, I can author, design, and edit my function chains. So these blue boxes, for instance, in this case, represents my layers within my map. And these yellow boxes, they represent various raster function chains. Each one of these raster functions are pre-configured with various parameters. This model essentially performs a weighted overlay or a weighted sum of all of my layers within my map. I can go ahead, apply this function chain. So here's my suitability map. It's processed on the fly. Now, as I pan around, I navigate around my map. This data set is processed on the fly. So this dynamic representation of my data is fine, it's sufficient in most cases. But there are several use cases wherein users require persistent data sets. And processing these volumes of data sets can take a long time. This is a typical big data problem. So using the new raster analytic capabilities, we have the ability now to send the same function chain to my WebGIS, which then distributes the processing across the available cluster of machines and creates my WebGIS layer directly into my WebGIS without any publishing requirements. Now, in the interest of time, I could kick off this process, but then in the interest of time, I have pre-created the layer, and here it's available within my WebGIS. And given that it resides within my WebGIS, it's accessible across the platform, be it desktop or be it the browser. So for instance, here you can see it available on my content. This is the layer. I've preloaded this. And as I navigate around this, I zoom and pan around. This is a persisted data set. And this processing is occurring at the source resolution. That's 30-meter resolution, all of North America that has been processed, 40 billion pixels. It took me 16 minutes to process, as opposed to 5.5 hours using the conventional desktop approach. Now, the analysis, or the WebGIS analysis that I just showed you using desktop, the same thing can be performed within your web browser. We've extended the analysis pane to include various raster analytical tools. So for instance, you could manage your data, you can apply masks, you can apply a raster calculator. Vegetation indices, you can apply terrain analytical tools, or out of the box, you have access to each one of the function chains that have been shared with you through ArcGIS Online. So for instance, the potential solar power plant suitability model that I just created in ArcGIS Pro has been shared with me through Pro, and it's now available in my contents, and it's available in my map right now. In addition to this, there are a couple other functions. This is another function chain, which is the filter optimum sites. Now, what this function chain does is it essentially uses the output of my previous processing chain, and it creates a more optimized result. So I can configure this and run the process. Again, in the interest of time, I have pre-generated this data set. So you can see I have a similar user experience compared to what we saw in ArcGIS Pro as well. Now, once I run the analysis, this is what the data set would look like. So the red depicts optimum layers that are suitable for solar power plants. So conceptually, this is what I've done. Once my slides come up. So here are my layers within my WebGIS. That's my input data sets. Then I use ArcGIS Pro to define my processing, author my processing, send it to my WebGIS. The WebGIS essentially, it distributes or it farms out the processing to the available cluster of machines. It works with your native GIS data sets. It can be optimally stored within your data store. The results are then written directly into your WebGIS without any publishing workflow required. This can be then consumed across various clients. Now, for the developers within the room, we have a REST API as well, which you can leverage. So as you can see, raster analytics, it brings a lot of value, a tremendous amount of value to your WebGIS. And the key takeaways, one, raster analytics is designed to work with large data sets. It's designed to scale. It scales to your organizational needs. And lastly, one of the key value propositions is time. What used to take hours now takes minutes. Thank you. And now I'll hand it over to Jay, who's going to be talking about the Python API.
Thanks, Vinay. That was an awesome overview of raster analytics. Joining me on stage is Rohit Singh. Today, we're very excited to talk about a new API, the ArcGIS Python API to the platform. It's a new API that accesses your GIS, which could be online or on premises, and it's intended for use by org administrators, content publishers, power users, developers, pretty much anyone who has a need to automate the system or script the system, and that includes analysts and data scientists too. So we're very excited to announce this and give you an early sneak peek at this. It all starts with your WebGIS. Let's see what it can do for you, this scripting engine. Basically, for administrators, it lets you manage your users, groups, and roles. For content publishers, you can create web maps and web scenes and web layers, and you can group them and you can share them. As a developer or as a power user, you get access to the full platform API through this Python API. And of course, if you're an analyst, you get access to spatial analysis, imagery. You also get access to location analytics. And if you're an analyst who thinks of yourself as a data scientist, you have access to all of the big data geoanalytics that you saw earlier today. So it's a very powerful API that we are building. So how does it all work? Through REST APIs. You access the full power of your WebGIS through REST APIs, and that includes the analytics that you saw earlier today. And that's a fundamental feature of the platform, and this API exploits that. The modules of this are pretty simple. It starts with your GIS, of course, and your GIS has tools, and it has layers that go into visualization in the form of web maps and web scenes. Pretty simple. Simply said, it's GIS made simple. Another view of the system is, if you start with your GIS, you look at users, groups, items, and you manage them, and you have tools to work with them. But it's probably best experienced through a demo. So Rohit, show us what you can do with this API.
Sure, Jay. So here, let's see what the Python API to your WebGIS looks like. This is a Python notebook. This is a browser-based Python console where I can type in my code that gets executed on the notebook server, and the results are displayed in the browser. To use our WebGIS, we create a GIS object. The GIS represents ArcGIS Online or your portal, and it lets you manage your GIS content, data stores, users, and groups, and it also has a map widget for use within the notebook to visualize the content of your GIS as well as the results of your analysis. So let's bring in a map of the Palm Springs region. We do that by calling gis.map and assigning it to a map variable that I'm then querying here. We can search for contents in our GIS, and I'm searching for hiking trails in the Palm Springs region. And for each item that gets returned, that is the web layers and web maps, I'm displaying them within the notebook. This brings a rich representation of these items within the notebook. And then we can add these to my map. I'd like to add the last result, the trails in Palm Springs, to my map. And we do that by calling map.addLayer and passing in the item for that layer. We scroll up to see that, yes, indeed, the map has been updated with the hiking trails. The GIS object has a rich collection of tools, including the spatial analysis tools, geoanalytics tools, and the raster analytics tools. And the full suite of tools is available within the notebook along with the documentation. Let's switch to a more comprehensive analysis that I had done of the recent floods in Chennai. And the complete analysis will be available at the Server GIS Island in the Esri showcase, where you could play with it. But I wanted to highlight a few things that make this API really stand out. I have some local rainfall data in this CSV file that I'm reading in using pandas. Pandas is Python's data access library that makes it really easy to use any kind of data. With this API, I can import any pandas data frame that has an address column as a layer in my GIS. I'm then adding that layer to my map and specifying that it should use the class size renderer for its visualization. So this visualization is bringing together the simplicity of Python, the power of pandas, and the smart mapping of the JavaScript API. For this analysis showing the flood-prone areas in the city of Chennai, I called the trace downstreams tool to identify the paths that water would take when released from the lakes and reservoirs in the Chennai region, and added the outflow paths to my map, and also added them as an input to the create buffers tool to identify the areas that were hardest hit by the floods. We can also use satellite imagery like this historical Landsat layer from the Living Atlas to see how this marshland that acts as a natural buffer zone to collect rainwater has shrunk to less than a third of its size in the past 2 decades due to urban sprawl and poor planning, and how this has also contributed to the floods. And finally, we see how we can look at the data behind our layers and at the data behind the results of our analysis, in this case, an aggregate points analysis, and bring it into a pandas data frame for further analysis or visualization using matplotlib. This shows the synergy that is possible by combining ArcGIS with the rich set of libraries and widgets in the SciPy stack and the Python ecosystem. Python notebooks are a great way to document, share, and do any kind of analysis. And it provides a platform for a reproducible research using geo-enriched literate content. In simple words, you will love them. Thank you.
That was awesome, Rohit.
Thank you.
Many of you will think of this like a joyful joystick to your GIS, right? Some of you might even relate it to AML and ArcPlot and Avenue. So how do you experience this? 2 ways. You can download the API as conda packages, use it like a native Python mechanism, or you can experience it like Rohit showed through the notebook experience. So we look forward to this. Thank you very much, Rohit.
Thank you, Jay.
So let's move on and just for a moment, zoom out a bit. That was a lot of capabilities and the platform that you saw. But how do you pull it all together? So just blank out for a moment, and let's start with the WebGIS. A basic WebGIS is your server with a portal. It starts with this. And then the next thing you do is you attach visualization and analytics servers to your basic WebGIS, like you see in this diagram here. And then what you do is you pull them all together, building the system, and then attaching the appropriate data stores. ArcGIS comes with data stores that are purpose-built to store the right data types for the right reasons. Or you can attach your own data stores and bring your own data to preserve the liveness of the data itself. So that's how you build your WebGIS. Then once you built it, you can publish your live data, or you can pour data into the system. And because there's identity and roles in the system, you can give users privileges to access the capabilities of the system and the apps that are part of the system itself, like you can see here. So that's how you build a system. And this is a WebGIS platform architecture that's very similar to what we have in online. Thank you very much. Back to you, Jim. Thanks, Jim.
Thanks.
Speaker.
Thanks. So, we have seen a lot. We have covered a lot of ground this morning. But what I want you to take away from what you've seen this morning is many different clients or apps and APIs that are all working against the common backend. That common backend being ArcGIS online in the cloud or ArcGIS on-premise. I mean, that's pretty amazing. Driving something with that capability and that vastness through a RESTful Python API, that gives all of you huge, huge leverage and accessibility to ArcGIS. So we've seen a lot. I know you're itching to get up. Let's get up, take a break, and let's be back in our seats at 10:25. We've got a lot more to show you this morning. Thank you very much.